So this video we pick up with number 37 on your EOC review packets. Now in this question they're asking you to find the area of your parallelogram. In a parallelogram our area formula is base times height, lowercase b for base. Now your base, the easiest one to consider our base would be the length of SR or the length of PQ. They should be identical. So if I count the boxes here, because they're horizontal lines, you can just count the boxes to find their length. It's going to go from -1 over to a +7 along your x-axis, so it's going to be 8 boxes in terms of the base length. And now the height. In this case, the height, it always has to be perpendicular, so the easiest way to draw my height would be from my base going down perpendicular to that length of 8. This would be my height that I just drew in. I don't want the length of each of the other two sides. That's not the height of my parallelogram. You want to imagine that height is when you take your shape and you sit it on a table and you measure how tall your shape would be. So in this case, imagine that this is the table and the height would be from that table up to the top of the parallelogram, up to PQ. So in terms of the height length, you're going to count the boxes again. So we have 1, 2, 3, 4, 5, 6, 7. 7 boxes for the height. So now we're going to plug in our base is 8 times our height of 7. 8 times 7, 56. So it's going to be 56 square units. Next question. Here we pick up again with a question that's asking us about lateral area. Now this question is asking us about lateral area because it's asking to find how much filter paper you would need to cover the lateral part of this funnel. Now I'm looking for that portion of the funnel because that's where the filter paper is going to stand. It's not going to go on the top portion of this funnel. There's no circle that's going to be covering the top. So I just want to find the lateral area of this funnel. Now I'm going to erase this and we're going to think about what shape this is. Now your funnel is clearly in the shape of a cone. I know that a little piece here is truncated at the bottom, but it's going to assume that it's not truncated. Imagine there's an entire cone here, and when you put in the filter paper, it's going to form the entire format of the cone. I'm going to erase this again. Okay, now if I'm finding the lateral area of a cone, that's a formula that you have to know. To get lateral area, the area of the curved surface of a cone, you're going to do the formula pi times the radius times L, the slant length. In this case, L, that would be this length right here, or the same on the other side. We don't have L in the diagram. What we have is a 7.2, which is your height. That's the height of this cone. I can take that 7.2, I can draw it on the inside, and again, I'm going to show that this is a height of 7.2. So they didn't give you the slant length, so we don't have everything that we need for our formula. Now we need to figure out how are we going to get that slant length. Now this one again, just like with all of the volume formulas that we've done before in surface area, we're going to find that slant length by using Pythagorean theorem, because what we formed is a right triangle on the inside of this figure. Now for my right triangle, I'm going to have to use a squared plus b squared equals c squared. Now in this case, I still need to figure out what my length is here for the right triangle, because 8.6 is the entire side. It's the diameter of your cone. So I need to get half of that to just get this black length at the top. Half of 8.6, 8.6 divided by 2, is going to equal 4.3. 4.3 is the radius of this cone, and it's also going to be the side length that we use with our Pythagorean theorem. So I'm going to start setting up my Pythagorean theorem. 4.3 squared plus 7.2 squared equals c squared. Now in my calculator, 4.3 squared gives me 18.49 plus 7.2 squared. So it's going to be 70.33 for c squared, which means that when I take the square root, I have approximately 8.3863 if I round to the fourth decimal place for the length of that slant, that c value, right, in centimeters. Now if I plug this into my formula, I have pi times my radius of 4.3 times the slant that I just solved for in my diagram, which is approximately 8.3863. And I'm going to multiply all of those together, and I'm going to get the lateral area of the cone, which is going to act as the area of the filter paper. Now I'm going to keep that 8.386 whatever in my calculator because it's going to keep it exact. And I'm going to multiply by the 4.3 and then again by that 3.14 that they want me to use for pi. So times 4.3 times 3.14 equals, and I get 113.2318. They're asking me to round to the nearest square centimeter. So just a regular whole number, no decimal places. So this is approximately equal to 113 square centimeters. Okay, next question. Now in this question, they give us the perimeter of a square. So I'm going to draw my square. Okay, so here's my square, and now they're telling me the perimeter of a square is 108. Now I want to know what's the length of each side. Now since it's a square, all four of your side lengths are going to be congruent. So I'm going to take 108, I'm going to divide by 4 to find each side length. So each side length when I divide by 4 is going to give me 27. So it's 27 centimeters on each side. The problem asked me to find the length of the diagonal. So the diagonal would go from one corner to the opposite corner, and it would divide my square into two right triangles back to back, because I know that any square has right angles in the corner. Now if I want to find out the exact length of this right triangle, I could do Pythagorean theorem, and that's always going to work, but let's also use our special right triangle information. So I'm going to break out that one right triangle to take a look at it. We have the two legs being congruent. They're both 27, and we want to find the length of the hypotenuse. If you remember, this special right triangle is called an isosceles right because it has two legs congruent. It is also called, famously, 45, 45, 90. Because if two legs are congruent, then these two base angles here have to be congruent as well, which means they each have to be 45 for the triangle to add up to 180, for all the angles to add up to 180. All right, now, based on how we do our special rights, each of the legs, we call those x, and then our hypotenuse is the length of the leg times the square root of 2. So this one would be x square root of 2. In this case, x is 27, so our answer for the length of the hypotenuse with absolutely no work involved is 27 radical 2. Now the question says what's the length of the diagonal to the nearest centimeter. So I want a whole number. I don't want a simplified radical. I don't want a decimal. So I'm going to put this into the calculator. I'm going to do square root of 2, which is approximately 1.4 yada yada, times 27, and I get that number, that 38.18. So I'm going to round this to the nearest whole number, so I'm going to round down to 38. So my answer here for the diagonal, 38 centimeters. Okay, next question. Now in number 43, they're asking us to match the equation with the graph of a circle. Now if you remember the generic form of any circle, it's x minus h squared plus y minus k squared equals the radius squared. Now, when you look for h and k, you're looking for what's being subtracted from the x and y value, and that's going to give you your center, h and k. And then you're going to take a look at the number at the end of the equation, and that's going to be your radius squared. So you're going to square root that number at the end to get the radius. So in this example, our center, if I take a look at what's being subtracted from my x value, it just says x squared. It doesn't have anything being subtracted from x. So my x value for the center is 0. And then for the y value, I'm thinking about what's being subtracted from y. What's being subtracted is a -2. Now, the quick rule is just take the sign that's already there and you're going to flip it. So instead of a positive, we're going to make that a -2 for our y value center. And then the radius, since this 4 that they gave us, that 4 is your radius squared, we're going to undo the square by taking the square root. Square root both sides, and 2 is the length of your radius. So let's find a diagram that has 0, -2 as the center with a radius of 2. Okay, so it's not choice F because the center is at 0, +2, so that's not it. Choice G, the center is at 2, 0, so that's not it. H is at -2, 0, so that's not it. Okay, and now I has a center of 0, -2, and the radius, if I count the boxes, 1, 2, is a radius of 2, so that's going to be our choice. So in number 45, they talk about a quadrilateral. So right away you want to make sure that you graph it because they give you this quadrilateral on the coordinate plane. They ask us to figure out which of the following statements is true. Now, from our choices, we have the option of choosing that this is either a rhombus or a rectangle. Now, you need to think about, well, what are the properties of a rhombus? And then what are the properties of a rectangle? Now, one thing I know for sure, just by looking at it, is that this is definitely not a rectangle. It's not a rectangle because there are no corners at I, H, K, or J. Those lines are not perpendicular, so I don't see any right angles. So that's why I'm going to say that it's not a rectangle. And I'm thinking about my properties of what makes it a rectangle, that there should at least be one right angle in one of the corners. Additionally, diagonals would be congruent if it's a rectangle. Now, what I'm thinking about for the rhombus is that all 4 sides are congruent, the diagonals are perpendicular, and the fact that the diagonals bisect the angles, well, I probably can't tell that from the coordinate plane. But the first 2 I can, so let's see what the choices are. So the first one says that this is a rhombus. Okay, I'll test that in a little bit. Part B says HI, which is the left side, is parallel to KJ. Well, the way I would test that is by using slope. So let me check to see if the slope of the 2 lines is the same. Now I'm taking a look at HI. I'm going to start at I. I'm going to rise 1, 2, 3, and run 2. So it has a slope of +3/2. Now for JK, again up 1, 2, 3 over 2. Again, the slope is 3/2, so yes, these are parallel. So that's something I know for sure. So that's probably going to be my answer. Now for the next one, for D, it says HJ is perpendicular to IK. All right, so they're talking about the diagonals. Now, if these 2 diagonals are perpendicular, then that means it's a rhombus, because a rhombus has perpendicular diagonals. It's a parallelogram shape that has perpendicular diagonals. Now let me check to see if these 2 diagonals are perpendicular. So to go from I to K, I'm going to rise up 1, 2, 3, 4. So my rise is a +4. And my run, I'm going over from -5 to a +6. So I'm going to count to the right 11 boxes. So my slope is +4/11. Let me check the slope of HJ. Now if it's -11/4, then it's perpendicular. So I'm going down 1, 2, and then over. So it's a -2, and then over from -3 to a +4, so over 7. Nope, those are not perpendicular, so it is not a rhombus either. All right, let's move on to the next video.